decorator pattern is a design pattern used in object-oriented programming languages like Java or C#. The pattern is used when you want to extend the functionality of a class without modifying the code. In this video, we're going to look at some of the use cases for the decorator pattern, and I'll show you an example of how you can implement it. Imagine you have an application written in Java or C# or something like that. And as you've developed it over subsequent iterations, the code has grown and grown and grown into something very large and complicated. Now there's a number of different ways that you can tackle a growing code base. Splitting it out into microservices is a very popular solution. But microservices come with their own drawbacks and they aren't right in every situation. So what else can you do to let you can continue adding functionality without drastically increasing the complexity of your code? Well, this is the problem that the decorator pattern sets out to solve. The decorator pattern lets you add functionality to your classes without adding more code inside them. Let's take a look at an example for this. Let's say you have a class that implements an interface and there's a method on that class that sends an email. Now this code is fairly small and it's fairly manageable. It sticks nicely to the single responsibility principle. This method has one responsibility, sending an email, and that's all it does. Now let's say that our requirements evolve and we want to extend the functionality of our application. Let's say we have a new requirement that says whenever we send an email, we also want to log into a database when the email was sent. You could of course just add another line of code underneath this here saying log to the database. But this is where the complexity of our method starts to get out of hand. The send email method is no longer just doing one thing, it's now doing two things. It's sending an email and it's also logging to a database. And you can imagine that as we grow the application and the number of different bits of code in here, it will just grow and grow and grow, and it can become unmanageable. So think about how you'd solve this with another class. Well, one option might be to create a subclass that inherits from this user notification service, and it calls base.sendEmail. And then in your subclass, you could perform the logging after that. Now this isn't terrible, and we have managed to separate the logging code from the email sending code. But extending code with subclasses like this carries its own problems. Your parent class is very strongly linked to the child class, and you can't really test the database logging code without also calling the email sending code. So an alternative way to achieve this would be to create this class, not as a subclass, but as a standalone class that implements the same interface. And it takes another instance of that interface as a dependency. This pattern here is called Dependency Injection, and I have another video explaining that in full. The link should be on the screen now, but I've also added a link to the description below. So anyway, we create our new class and we call it User Notification Logging Decorator. This class is our decorator, and this is what makes it the decorator pattern. We're decorating whatever this base implementation is here with login logic. And down in the method, instead of calling base.sendEmail, we call implementation.sendEmail. So now we have a completely separate standalone class that contains our logging logic, and we can test this separately by passing in an empty mock into the constructor. So we've achieved that goal of being able to test our logging code without calling the email sending code. To use this decorator class, we need to do some setup in our dependency injection container. Again, see my video on dependency injection for the explanation of containers, but since this is C#, we can just modify the line that registers the user notification service, and we can tell it to use a new instance of user notification logging decorator with user notification service passed into the constructor. Some dependency injection frameworks actually have special functionality specifically for registering decorators, as this is a fairly common pattern to use in an object-oriented software design. So just to summarise, we use a decorator pattern when we want to add functionality to a class without modifying the code inside the class, and without creating strongly coupled subclasses from them. By creating these special decorator classes and injecting the original object as a dependency, then we can nicely separate out our concerns and keep our code in these smaller chunks that are loosely coupled to one another. I hope this video has been useful. If it has, then please subscribe to my channel. If you've got any questions on this or any of the other design patterns that I've explained on this channel, then please put them in the comments section below. I will respond to every comment because we're still quite a small channel. Check out my other videos for more software design principles and general tips and advice. My name's James, and I'll see you in the next video.